Hi, good morning all of you. Welcome back to a new session today. We will be doing continuity and differentiability of a function, and this particular topic has been divided into different modules and beginning with continuity. But before we go into continuity, children, you need to understand what you exactly mean by continuity. So, as the topic itself names, continuity and differentiability. So, when I say continuity, what does it actually mean? Let us understand it first. I am going to give you three particular cases on the graph. So, let us begin with this part clearly. The first thing is, suppose I give you a graph here, okay, 1, 2 and finally 3. Now, what happens in this case? I want you to make it understand. I am going to three situations A, B, C. Then finally, this is x axis, this is y axis, x axis, y axis, x axis and y axis. Now, what you see across, now I draw a graph in front of you, just a second. Okay, this is a function, this is a curve of a function. Okay. Now, I had given you three situations and I just want to mention this point is A, okay, this point is B and this point is C. Now, this is just labeling A, B, C. The x axis value is A, x axis value is B, x value is value C. Now, when I talk about continuity, now you all know that this is represented by a particular function. This curve might be of some function. This curve also might be of some function. So, what you understand? Now, when you look at the graph in this perspective, you see that the graph is moving continuous, there is no break in the graph. But if you see carefully, there is a big hole in the graph. Can you see this hole? Yes. So, that means that this function is not continuous. It might be continuous at this particular point, children. It might be continuous at this particular point, at this particular point, at this particular point. But at this particular point, it is not continuous because there is a hole in the graph. Now, if I ask you to conclude, find whether in this graph the function is continuous, you will see that here it is continuous, here it is continuous, but at this particular point, there is a big jump in the graph. There is a big jump in the graph. So, when I say big jump in the graph, it means the function is continuous up to point B, and from there at point B you can see there is a jump. So, it is not continuous, it is a discontinuous function. So, this you exactly mean by continuous and discontinuous. By looking at the third point, it will become more clearer to you what they mean. Look at the graph here, this function is moving, moving, moving. If you see here, there is no break at all. It moves further. That means if you see in the first graph, there is a hole in the graph. That's why I can say the function is discontinuous. In this case, you can see there is a big jump, discontinuous. In this case, there is no break at all in the graph. It's a smooth sail of the graph. So, as there is a smooth sailing of the graph, I can say that this function is continuous. So, question arises. So, it's very easy. Fine. I want to remind you, look at this particular point. A graph is put in front of you. I can see the graph and tell, oh, it's discontinuous, it's discontinuous, it's continuous. But what happens, suppose if I give you a function in terms of say an algebraic function x square plus 2, and I say discuss the continuity of this function. Now, when I say discuss the continuity of a function, if you take these examples which I have put across, I always discuss the continuity at a particular point on the curve, at a particular point on the curve, at a particular point on the curve, because the other part it is continuous. So, whenever you are discussing the continuity, you always discuss a continuity of a function at a particular point, or you can say between B and C. In an interval, you can discuss the continuity. Two variations. So, fine. Coming back to what I put across to you all, I still told you all function is given to you, graph is there, I am very happy, I can discuss the continuity at A, it is discontinuous, at B it is discontinuous, at C it is continuous. But what happens if I say that at x equals to A, suppose this function I told you that this function is x square plus 2 at x equals to A, I have not given you any graph. When you see, it becomes easy to interpret. But here there is nothing to see because there is no graph. So, as there is no graph, it is very difficult to find whether the function is continuous or not. So, here this topic of continuity comes to your rescue. This topic of continuity is going to help you to find whether the graph of this function is continuous or not at x equals to A algebraically. It means that you are going to learn how to find a function is continuous or not with an algebraic method and not graphical method. So, this is an important point you have to keep in mind. The full topic of continuity is just to find whether the function is continuous or not, as the third case, without drawing the graph. That means algebraically. So, what is that concept? How we find algebraically whether the function is continuous or not? Let us see in the next slide. Pause and note it down. I hope you understood this point clearly. Okay, go ahead. Copy it down, children, properly. Let us see this part now, children. Now, as you saw, what do you mean exactly continuity? The objective of this topic is nothing but finding whether the function is continuous or not at a particular point A. Keep in mind, at a particular point A, we discuss the continuity, right? Or within an interval A to B. Having said that, we are going to see an algebraic method to find whether the function is continuous or not, because we are not going to draw a graph of a function and find whether it is continuous or not. So, what is that algebraic method? Let me just elaborate. So, please take it down what I am showing you on the board. X axis, y axis. I am just drawing a curve for your information. For example, this is f of x, okay, and at this point I am discussing the continuity of this function, okay, at this point A. Fine. Now, I want to share with you something very, very important and interesting now. First point you have to understand, for discussing the continuity, there are three options, three conditions. Basically, before that, I will just explain you some terms. Any value less than A is denoted as A bar. Any value greater than A is denoted as A plus. Okay, A plus. Now hold your breath. This part is called left hand limit. This part is called right hand limit. And at this particular point, it is nothing but f of A. So I would just put across this in a algebraic way. What is this thing, this part? As I said, this part I can say limit of fx as x tends to A bar. This is greater than A. So this I can say this part limit of fx as x tends to A plus. And finally at this point it is nothing but f of A. Now what they have to say is, keep in mind, if the left hand limit and the right hand limit gives you the same value. Now remember, when I say A bar left of A, matlab you don't try to take the value at A, in the vicinity of this particular point. So very small decrement, very small increment. At this particular point, you try to find the value of f of A. I mean to say, the function approaches which value? The function approaches which value when it moves up. Now when I say f of A, okay, this is my left hand limit, right? If suppose if this is the function, the limiting value of the function which approaches this part, and when I approach towards this side, I mean to say I approach towards this side, this side the value of this function also resembles the same thing. So this value is equal to this value. So what happens, children? As it approaches A from the left hand side, may I have attention here, this value corresponding is nothing but f of A. Similarly here, if you are approaching A from the right hand side, okay, then this particular value is f of A. So what I mean trying to tell you is, the left hand limit value, the function approaches what value? F of A. The function approaches what value from the right hand side? F of A. If this value is equal to this value, then I say that the limit exists. I am not spoken about continuity. What I said, if the left hand limit is equal to right hand limit, I say limit exists. And if this value, now for example, suppose this value has come, say, you can say this value has come, say 4. This value has come 4. And this f of A, look at this point, this f of A is also 4. This f of A is also 4. Then I say that the function is continuous and there is no break in this graph. Now this we are doing directly without using graph. So this is just an interpretation of, the working of the method, how to find whether the function is continuous or not. So what I said, you are approaching A from the left hand side. So the function approaches what value? 4. From here the function approaches the same value 4, and at f of A also it is 4. So then I can say the function is not only existing, the limit not only existing, but the function is a continuous function. There is no hole, there is no jump at this point A. So if I want to interpret this, on a algebraic format, so I can say left hand limit is equal to right hand limit is equal to f of A. So the function will be continuous if left hand limit value 4, right hand limit value 4, and f of A is also 4. Now this is a slight very important thing, but when I show it algebraically it becomes very easy to understand. Now left hand limit, what it implies? It implies limit of f of x as x approaches a bar is equal to limit of fx as x tends to a plus, that is the right hand limit, is equal to f of a. Now this is the condition, I mean to say this is the method to find out whether the function is continuous or not at x equals to a. Sometimes what happens? This is true, that is the left hand limit is equal to right hand limit. So I say limit exists, but I can't say continuous. If that is equal to f of a, then I say that the function is not only existing, the limit is not only existing, but the function is also continuous at x equals to a. Now this is a very important. Now when I see at this particular point, this is the exact mechanism by which we use an algebraic method to prove whether the function is continuous or not at this particular point A on the curve. So you must say, so we got it. Now if you see this word limit, what you studied in class 11 in limit, how to evaluate the limit, the same thing you are going to do. So this is the sum in a bar, that is left of a plus right of a. I mean to say small, you can say a bar means a minus h, because you can say a bar, it means suppose you take a small decrement here h less than a and greater than will be a plus h. So that's the way you understand, that's the way you deal with this. So this is the way of proving or finding whether the function is continuous or not at x equals to a. So I hope you got this method. Very important formula, children, right? And I want you really to copy this formula, but this is going to give you help in each and every sum on continuity of a function. So I hope I made myself very clear. So please take it down. Any further clarification, you can always revert back to me. Pause and note it down carefully without committing mistake. Okay, let us see the first type of question, children, which is very clear, that f of x is equal to x minus 3, x less than equal to 0, x square x greater than 0. Discuss the continuity of the function x equals 0. Before we proceed, I just want to remind you how to read the sum, because this is normally children don't understand even though they are finished with the functions part in class 11. Now please understand what I am trying to share with you. This function are given in pieces. Now if you look at this, when x is less than 0, this function is valid, x minus 3. When function is greater than, when value of x is greater than 0, this function is valid for that. So in a number line you have 0, the positive numbers and the negative numbers. So in short, remember, this function is valid when x is less than 0, when this function is x square is valid when x is greater than 0. So this you have to understand this part first. Then it's very easy to get to the basics of the continuity. But before we proceed, discuss the continuity of the function at x equals to 0. So when the function is continuous, if and only if my left hand limit is equal to right hand limit is equal to f of a. Now in this case a is what? 0, because at x equals to a you need to understand it. So what I do is, if all the three values are equal, so algebraically I am talking about, if all the three values are equal, then I say that the function is continuous at x equals to a. So basically what you do have to do, algebraic means what? So let us write the sum clearly. So what will happen in this case, I can write this way, limit of fx as x tends to left hand limit, that is at 0 they are asking us to find. So left of 0, so you can say x tends to 0 bar. I am not saying it is equal, okay, I am just trying to, so limit of fx as x tends to 0 plus right of 0, and this is of course it is f of 0. So children, what I meant by saying that LHL equal to RHL, you have to find the values of this separately. Once you find the value here, you find the value here, you find the value here, if all the values are equal, then I said that the function is continuous at x equals to 0. Okay. Once you identify that this is the formula I have to apply. But you go to next case is, what is the function? There are two functions, one is x minus 3, one is x square. So which function you will consider to be true? Which function you will consider? Let us take 0 bar. Now 0 bar, I mean to say left of 0. Left of 0 means what? 0. Left of 0 means less than 0. So less than 0, which function is valid? X minus 3. So let us proceed. So I have to write which function is valid for this. So function is there fx. So less than 0, it means x minus 3. So this function is the limit of x minus 3 as x tends to 0 bar. Similarly, 0 plus greater than 0. Greater than 0, which function? When x is greater than 0, this function is valid. So limit of x square when x is tends to 0 plus. And f of 0, I think is very clear. What is f of 0? When equal to 0, it is, I think you can just write on this value exactly. I will come to that. So we can just write on that function as it is. It is nothing but x minus 3. So once you understand what is my left hand limit, which function I have to consider, what is my right hand limit, which function I have to consider, what is my f of 0, I start evaluating the values of it. But one very important point in limits you had studied in class 11, whenever you have a situation like limit of fx as x tends to a minus or plus, you can't evaluate the limit directly. Because a minus means any value less than a. A plus means any value greater than a. So you can't just say a minus means take a minus accordingly in all the sum. It can't happen. So what I will do, in place of x tends to 0 bar, I will specify a value. I will take h as a small decrement, as well as in this case h as a small increment. H is very, very minute. Suppose if it is in the graph, right, this is a point, then h will be just in the neighborhood of a, in the neighborhood here, in the neighborhood of a, very near to a. Okay, so that part we will take. So let h be a small decrement. So first step, as it is 0 bar, I can say let x be equals to 0 minus h. H is a small decrement than 0 because left of 0. In this case, let x be equals to 0 plus h. Why I do? But this becomes a specific value. Okay, so at this value you are going to find the value of that limit of the function, what it approaches as x approaches less than 0, that is very close to 0 on the left hand side, and at x equals to 0. This is, of course, this is not an issue. This is understood at x equals to 0. So having said that, now let us see what happens here. So x equals 0 minus h. So what will happen now? Just I want you to understand, just pay attention now. So limit of x is replaced by 0 minus h. So it is 0 minus h minus 3. Now remember, if the function is in terms of h, the limit also has to be in terms of h, right? Limit also has to be in terms of h. Now very simple. Now I had put x equal to 0 minus h. Now look at this limiting value. If x becomes 0, because you can't change the meaning of the question, if x becomes 0, if here it is given x tends to 0. So if x becomes 0, what will h will become? If x becomes 0, h will tend to 0. So that is a complete part by which I can solve this sum. Similarly here, right, x tends to 0 plus h. So what will happen now? Just see, x tends to 0 plus, replace the x by 0 plus h. But as the function is in terms of h, you need to change the limit. So x becomes 0. So if x, look at the substitution. If x becomes 0, what will h will become? 0. And here there is no issue at all. I can get the value right away. So once you get this, I think the denominator is a nothing but 1. I can take the limit directly. So in this case, what is the value? I will tell you. H is 0. So minus 0 minus 3. Answer is minus 3. Similarly here, if you see 0 plus h whole square, 0 plus h whole square, h is 0. So what is the point value here? Directly you can take the limit, it is 0. Now f of 0. Now by the way, this is my left hand limit. This is my right hand limit. They are not equal to 0, not equal to each other. So if my left hand limit and right hand limit is not equal, there is no need to check the continuity at all, because the limit does not exist. The limit does not exist. So my left hand limit is -3 and the right hand limit is 0. So I strongly feel that, I'll just put it across. So I hope you got this point clear. Very interesting part, children. Okay. Now you need to understand -3, I got the value here 0. They are not equal to, I mean to say the left hand limit is not equal to right hand limit. This is the value of left hand limit. This is the value of right hand limit. So every sum you have to do this compulsorily. The functions keep changing. So left hand limit is not equal to right hand limit. Limit does not exist. So if it does not exist, there is no need to see for continuity at all, because these two values has to be same to go further for f of 0. So even so, you want to go for f of 0, fine. So f of 0 means what? When x is equal to 0. So x is equal to 0, this function you are taking. So 0 minus 3. So f of x is x minus 3. F of 0 will become x will become minus 3. Right. So even though these two are equal, but these are not equal, so there is no need to look at all. There is no need to look at all further. So I mean, in this case, the function discuss the continuity. Therefore, you can just add a conclusion here. Therefore, the function is discontinuous at x equal to 0. 2 points I want you to explain here. Left hand limit I got, fx x tends to 0 bar, because at 0 you have to find. 0 bar is not a value. 0 bar is just a notation which values you have to take. So 0 bar means left of 0. So I just introduced that h. H is a small decrement in 0, less than 0, small, very minute. So I put x equal to 0 minus h. So I replace this 0 minus h in this case, x as 0 minus h. But remember, as the function is in terms of, see, the function in terms of x, limit is in terms of x. The function in terms of h, the limit has to be in terms of h. So how I get the h limit? Very simple, x equals 0. So if x becomes 0 in this case, the h will become automatically 0. Check 0, 0, 0, h 0. Similarly, this is the way you have to do. The same thing I am going to repeat in each and every sum, children. So definitely, if you understood 10 to 15% of what I explained you now, remember one focus for continuity: left hand limit, right hand limit, f of a. This is important for all of us. And this is just a basic maths what we did in class 11. This is the basic maths of class 11 what we had done. And of course, this is a very simple part. So please understand this part of the working on discussing the continuity of the function at x equals to 0. So I hope you got this point clear. Pause and note it down carefully. More and more clarity will come as you go up sum after sum. So please take it down. The next question on display, children. The function is given in pieces. This function is valid when x is less than or equal to -3. This function is valid when x is between -3 and 3. 6x plus 2 when x greater than 3. So this function is given in pieces. Fine, I have no issue. Now this is a point of question, very important, that discuss the continuity of the function at x equals to -3. So when a function is continuous, if you remember what I told you, if and only if left hand limit is equal to right hand limit is equal to f of -3. So first, to evaluate this part, you need to write it properly, what function we are going to use for solving it, what function we are going to use for solving the right hand limit, and all the stuff. Now f is at x equals to -3. So left hand limit will be left of -3. So limit of fx as x tends to -3 bar, limit of fx as x tends to -3 plus, and finally f of -3. I can write it down once again as it is. Now this, right, you have to find the value, this you have to evaluate, this you have to evaluate. But to evaluate, children, you need to know what function you have to consider. So x tends to -3 bar means left of -3. Now look at the question here. When x is less than -3, left of -3 means less than. So less than minus 3, which function you will consider there? Look at this, the first one. So I can write this as, I will consider this function limit of modulus x or absolute value of x as x tends to minus 3 bar. Similarly here, 3 minus 3 plus. So minus 3 plus, which function you will consider minus greater than minus 3, second function. Okay, now this is not minus 3 plus, please, minus 3 plus in the neighborhood of minus 3, that is a very small increment. So I think the second function is very clear. So limit of function is minus 2x as x tends to minus 3 plus. Now a very important thing here, f of minus 3 equal to minus 3, I think is the same function here. So modulus x plus 3, because this function is valid for not only less than minus 3 but equal to, when x is equal to minus 3, I consider the same function. So once you identified which function you have to consider, I had told you, I want to remind you that we can't continue with this because it is minus 3 bar. You need a specific value for x. At x equals to minus 3, the minus 3 bar means all the values less than minus 3. Minus 3 bar, all the values are greater than minus 3. But so at in the vicinity, in the neighborhood of minus 3, next to minus 3, left of minus 3, excuse me. So let us see this part. So what I am going to do is, I am going to use some substitution here. So left of minus 3, let x be equals to minus 3 minus h, left of minus 3. And similarly, I can say here x equals to minus 3 plus h, and this is at x equals to minus 3. So you can just write down at x equals to minus 3. So once you identify this pattern, I know, but remember, you cannot evaluate the limit. So I am replacing x by minus 3 minus h. So what happens, children, here? Let us see. So I will just write it down, limit of, now look at this pattern, x is replaced by minus 3 minus h, this is plus 3. Now remember, the limit has to change because this function is in terms of x, so limit is in terms of x, this function is in terms of h, the limit has to be in terms of h. Now use your brains. Now x is, look at the question, x is tending to minus 3. So here in this substitution, if x becomes minus 3, then minus 3 will get cancelled. I'll just make my point here. Suppose x equals to minus 3 minus h. Now what is the limiting value? That is x tends to minus 3. So if x becomes minus 3, then this will get eliminated and h will become what? 0. So keep that in mind. Now this is something very important I want you to realize, because many times what happens is students don't understand the working of it properly. So I just want to take you back to that particular point. So I hope you got this message clear. So let us see this beginning now. So here I got h tends to 0. Why? Because when x becomes minus 3, h will become 0. Similarly here, which function you are considering here? X is replaced by minus 3 plus h. So I can just write it, limit of minus 2 minus 3 plus h as h approaches 0. So this becomes specific value, this becomes a specific value, and x equals to minus 3, I have no issue at all because it is nothing but, you can just, if you want, you can put it up, minus 3 plus 3. Now once you understand this, I have to evaluate this limit sum, I have to evaluate this limit sum, I have to evaluate this limit. And finally I get the answer if all three values are equal. And remember, one thing I want to share with you, if your class 11 limit is strong, this working is very simple. This working is very simple, keep that in mind. So let us see this part. So limit of minus 3 minus h plus 3, it's a modular sign, h is tending to 0. So I can take the limit because the denominator is 1. I can take the limit here. So this will become, if I take the limit, it will become minus 3 plus 3. So now absolute of minus 3 is nothing but 3 plus 3. So the answer is 6. Similarly here, in this case, limit of minus 2, I am taking this as 0 here. So minus 2 into minus 3, here also I am getting plus 6. Similarly, absolute sign of minus 3 here, minus 3, right, that is 3 plus 3, that is nothing but, if you want, you can write it out, I have no issue at all. This is the absolute sign, okay, just don't bother this. So I want to say that is nothing but 3 plus 3, answer is 6. Now what you observe? You observe that left hand limit is 6 value, right hand limit is 6 value, and f of minus 3 6 value. So now what you conclude from it? The limit exists because LHL equal to RHL. 6, 6, 6. All the three values are equal. So as I can say that the left hand limit is equal to right hand limit is equal to f of minus 3. What is the conclusion you can draw? As all are equal to each other, what is the conclusion you can draw? The conclusion is as LHL equal to RHL is equal to f of minus 3, the function is continuous at x equals to minus 3. So never forget to write that point here. So please remember that point you have to write. So you should say as LHL is equal to RHL is equal to f of minus 3, therefore the function is continuous at x equals to minus 3. So here if you see, it's basic maths, you have to just solve and find the value of that left hand limit. You have to find the value of right hand limit by using your class 11 limit knowledge. That's it. That's why I said if your class 11 limit is good, you are through this topic straightforward. So I hope you got this point clear. We will be seeing more examples to give you more clarity on this. So just go through that properly. Okay, pause and note it down without any mistake. We will see more good sums into it. So take it down, children, without any mistake. Okay, children, the third question of our lecture is displayed on the board. Fx is equal to x square minus sin x plus phi. So it's a one single function. It's a very simple question. But when I look at the question, discuss the continuity of a function at x equals to pi. So pi is some value, don't worry about it. It is 180 degree or whatever in radians, degrees, whatever stuff it is. At x equals to pi, you need to find whether the function is continuous. So there is only one single function. So whether for left hand limit, right hand limit, anything, you have to consider the same function because the function is not given in pieces. So let us begin. So first step, everybody knows when the function is continuous, this you have to mention it to the teacher if and only if left hand limit is equal to right hand limit is equal to f of pi. This is an interesting fact. If and only if. So the teacher knows that you know the concept. Okay. Then finally, let us begin with the question now. First of all, as I said, left hand limit, let us write it down properly. So this will become limit of fx as x tends to pi bar because left of pi. Remember this bar and plus only tells you from which direction you are approaching pi. Left of pi, pi bar. Similarly here, limit of fx as x tends to pi plus. That's very interesting. And f of pi is nothing but you can say at x is equals to pi because at exactly pi, not right, not left, at pi. Once you finish with this, you have to identify which function you have to consider. Now there is only one single function, so it will be the same function for all of the cases. So limit of fx, so what I can do is I can just write x tends to pi bar, f of x is nothing but x square minus sin x plus 5. Similarly here, limit of x tends to pi plus, that is nothing but x square minus sin x plus 5, and finally here also in fact it will be x square minus sin x plus 5. So once you have decided that pi bar, I told you pi bar, a plus, you cannot define the limit. You have to get a specific value less than pi. So I take a h as a small decrement. So I use the substitution here. I will put x equals to pi minus h because left of pi. Here I will put x equals to pi plus h. So I will just put the word let so that it will be clear. And here there is no question. It is nothing but x is equals to pi. Now left hand limit is coming up down, right hand limit is coming up down, f of pi is coming up down. You have to evaluate, that's it. Now as I said, you are replacing x by pi minus h. So the limit of, so this will become pi minus h whole square minus sine of pi minus h plus 5. Similarly here I can say it is limit of pi plus h whole square minus sine of pi plus h plus 5. Now immediately remember it's pi minus h. Now x tends to pi bar. Now I had put x as pi minus h. The limit has to come in terms of h. Now look at it. Don't change the meaning of the question. See, x tends to pi. So look at the substitution here. If x becomes pi, what h will become? Pi will get cancelled and h will become 0. H will become 0. And in this case there is no issue. For x tends to pi, it is nothing but, you can evaluate this if you want. So pi square minus sine pi plus 5. So this is my left hand limit, children. This is my right hand limit. This is f of a. Once you finish with this, I have working to be done now. So basically there is denominator is 1. So I can take the limit if you want. You can take the limit directly also in this case because denominator is 1. But before that, sin pi minus h is, I think, sin h only. So okay, I'll just evaluate this for your convenience. So limit of h approaches 0. There is no need to do it, but still you can do that. It is pi square minus 2h plus h square minus sin 180 minus theta is cos theta, sorry, sin theta. So sin h plus 5. Okay, now I will evaluate this part. So as denominator is 1, I can take the limit. So h is 0 in this case. So h is 0. So this will become 0. Sin 180 is also 0. So what is finally left out in this case? It is nothing but pi square. This is 0, 0, 0 plus 5. So it is nothing but pi square plus 5. Right, my left hand limit. Similarly, let us come to right hand limit now in this case. Now if you see the right hand limit, can work, differentiate. Okay, now I'll just write. Now look at this point, limit of this will become pi square plus 2h plus h square minus sine h plus 5 as h approaches 0. Now once you are done, I think this is h tending to 0, h tending to 0, sin 180 is also 0. So finally the answer in this case, if I take the limit, it will be pi square plus 5. So pi square plus 5, pi square plus 5. Now third part is f of a. Now this I just brought it here, I am sorry, just take it out. So it is sin 180 is 0. So I am getting directly the value here, pi square plus 5. So what you observe? You observe the left hand limit is pi square plus 5, right hand limit is pi square plus 5, and f of a is also pi square plus 5. So this is what exactly I want to share with you. This is what exactly I want you to work. That is, if you see the left hand limit is pi square plus 5, right hand limit is pi square plus 5, and f of pi is also pi square plus 5. Therefore I can say, therefore as LHL is equal to RHL is equal to f of, I think, pi. Right, all three values are same, right, all three values are same. Therefore I can say that the function is continuous at x equals to pi. The function is continuous at x equals to pi. So be clear about all this working, one, second set and third set. I hope you got this point clear. There should be some confusion. What I would suggest is write LHL, solve it, write LHL, solve it, write f of pi, solve it, so that you are clear about how we are going about with the sum. So I hope you got this point clear, children. Pause and note it down because there is something very good sum, but single function is coming up. So I feel it's okay. I hope you got this point clear. Okay, good. Take it down, children. Okay, children, let's look at the fourth question, I mean to say. A function is given fx sin x upon x plus cos x, x greater than 0, then 2 when x is equal to 0, 4, 1 minus root of 1 upon x, x is less than 0. Now, there are three different functions are given to you, pieces, no doubt. Discuss the continuity of the function at x equals to 0. So, as I said, let us begin with the question now. It will be just clearly bifurcated properly so that you understand what you exactly mean. So first thing is left hand limit at x equals to 0. So left of 0. So your first part will come here, that is nothing but limit of fx as x tends to 0 bar. So let us begin now with the solving part of this. So when I say limit of fx as x tends to 0 bar, children, the point over here I want to show 0 bar left of 0. Now look at the function here. X is less than 0 means left of 0. So left of 0, this function is valid for us. So let us write it down, that function. So this will become limit of, this is 4 1 minus root of 1 minus x upon x as x tends to 0 bar. This is my left hand limit. I am evaluating it. I want you to focus on the board. 0 bar, I can't take the limit because it is left of 0. So all values left of 0. So in the vicinity of 0 I will take. So what I will do is I will put let x be equals to 0 minus h. So what will happen finally? This will become limit of 4 1 minus root of 1 minus 0 minus h, right, upon, this is nothing but 0 minus h, because all the x in this case I am replacing by 0 minus h. So as h happens to be, so x becomes 0, so h will automatically become 0. So my sum is complete in all respects. So now children, very important now, if you see this carefully, if you remember, it's a limit of root. So when limit of root is concerned, how you solve it? Rationalizing. So let us rationalize it. I'll just take it little bit behind so that you understand and fix it up accordingly. Now, x tends to 0. So I believe it will be 4. This is 1 minus root of, I think minus of minus is 1 plus h upon, it is minus h. Now to rationalize the numerator in this case, this is nothing but root of, that is 1 plus root of 1 plus h upon 1 plus root of 1 plus h. So what happens finally in this case, right? Now if I rationalize the numerator, this will be something limit of h approaches 0. Now look, 4 will remain as it is, and this is a minus b, a plus b, right, this part and this part. So a minus b, a plus b is a square minus b square, check it yourself, upon, what happens here, minus h as it is, right. What is left out here children? This is 1 plus root of 1 plus h. Now having said that, what happens? Now let us begin with this. This will get cancelled, minus h will get cancelled with minus h. So if I take the limit now, because if you look at the denominator, it is h is 0. So 1 plus root of 1 is 1. So 1 plus 1 is 2. So 4 upon 2. If you take the limit, you will going to get, if I take the limit here, you are going to get 4 upon 1 plus 1. Please try to work it on your own. That is 1 plus 0 is root of 1. 1 plus 1 is 2. So 4 upon 2 is 2. So this is the way of functioning with the left hand limit. So I got the left hand limit as 2. Now let us talk about the right hand limit. Now right hand limit, what is the writing part? Limit of fx as x tends to 0 plus greater than 0. So look at what function is greater than 0, x greater than 0. Which function is valid? This one. So write down that part. So limit of, this will become sin x upon x plus cos x as x tends to 0 plus. But 0 plus cannot be the working, so I will say let x be equals to 0 plus h. Replace in the sum. So limit of, this will become h tends to 0 now. This will become sine of, now 0 plus h. Look at this x part. I am putting x as 0 plus h. So 0 plus sine h upon h plus cos h. So it's very simple now. I think I can work out. I can directly take the limit, because limit of sine theta upon theta as theta approaches 0. Do you remember something? Limit of sine theta upon theta as theta approaches 0 is what? 1. So I can take the limit 1 plus, this is cos 0, right. So if you feel that, you can just write it down, cos 0. I am taking the limit. So this is nothing but 1 plus 1. This answer is 2. Now what you see, the right hand limit is 2. Now let us come to f of 0, x equal to 0. Look at this, x equals to 0 in this case, right? Now tell me, when x is equal to 0, what is the function value? 2. So there is no need to solve, this is already given 2. So my left hand limit, if you see carefully in this case, my left hand limit is 2, my right hand limit is 2, my f of 0 is also 2. So this is 2, this is 2, this is 2. So what you will conclude, children, in this case now? So you can say as LHL equal to RHL is equal to f of 0. All three values are 2, 2, 2. I can say therefore the function is continuous at x equals to 0. So this conclusion is very important. Subject to left hand limit is same as right hand limit is equal to at x equal to 0. So I hope now it is very specifically clear to you all, how the working is to be done. So identify the function, right? Identify the function, children, for left hand limit. Don't go at 0 bar or a plus, a minus h, a plus h, and f of 0 as it is falls down. So I hope you got this point clear, right? So please take it down. This is a very, very nice sum. So just build up your situation in this way.